Hello, Chandler here with Skill Above, RVtesters.com, and I wanted to take a few moments and do a little training session on electric brakes for trailers. What we want to explain today is how the brake magnets are an inductive load with resistive characteristics. So we are going to show you guys that with our long runs, typically 14 gauge wire from our 7-way plug back to our brakes, that the more hubs that we add to this, the more voltage drop we're going to have along this run, which is also going to cause each one of our brake magnets to draw less current because they have less voltage. So when we do our test, we're going to be showing it on 13.7 volts, 12 volts on a lead acid battery, and 6 volts on a lead acid battery. And we're going to show you the difference when voltage drops, amperage drops, and these things do not react the way that you think that they may. So if we come over here and do a test and that hub right here draws 4.5 amps, we can't multiply that by the amount of hubs that we have to get our total amperage draw as to what we should be seeing, because each hub that we add is another load onto that 14 gauge wire, which means the voltage is going to drop, which means the amperage is also going to drop per wheel. So we're going to prove that because we do have this test device or test stand here where we can turn on each individual axle, but also we can turn off a single hub at a time. And so what we're going to do is we're going to do a test with 1 hub, then 2 hubs, then 3 hubs, 4, 5, and 6, and then a total altogether. But also what we want to show you guys is that a cold hub versus a hot hub is going to draw a different amperage. So when we energize that brake magnet, it is going to start heating up. It's a coil. And when that coil heats up, the resistance value is going to increase, which means our amperage draw is going to decrease. Okay, let's get started. What we have here is multiple meters. We have a Klein CL800 amp clamp. We've also got the ideal amp clamp, and then we have the amperage reading on our Tow-Minator here. And so we're going to be doing a quick look at this, but as I said earlier, when these magnets heat up, the amperage draw is going to drop. So you compare this, the ideal meter versus the Tow-Minator, or the ideal meter versus the Klein meter. By the time we get it all switched out, you're going to see a difference because of the heat. Now, one thing to keep in mind with the Tow-Minator is we do have logic in here. We do have controls. And so resting, it is setting at 0.15 amps. Nothing is connected. It is just a box. But if we activate the brakes, you will notice that our amperage draw comes up to 0.41 amps. So the Tow-Minator with nothing connected is 0.41 amps. So what that means is we're going to have to subtract that 0.41 from any one of our readings that we get on our brake system so that we can get it down to 0, just like these guys right here. The first test we're going to do is we are going to hook on the Klein CL800 to this loop right here. This is our brake wire that goes down to all of these brakes. So basically we've brought it in here so that way we can monitor this. I'm going to zero down again. And then we're going to do our first test on 13.7 volts. So we are at 7.9 and 18.2. 17.9 and 18.2. We are going to subtract 18.2 minus 17.9 equals 0.3 amps. Well, look at that. We're right there. So what that tells us right there is this and this meter are reading within 0.1 amp of each other. So these two are right in line with one another. All right. So now that we've proven that, now we are going to do the amperage draw of 1 hub right here. We have switched all the other ones off, and we are going to activate just the magnet in this hub. 4.67, okay? And all of my black writing is going to be 13.7 volt lithium. Okay, so I'm going to be taking our amperage readings right here, and 4.67 minus 0.4 equals 4.27 because of this guy right here. All right. So our amperage draw of hub 1 is 4.27 amps. Now what we're going to do is we're going to turn hub 2 on, and we are going to repeat our test. 8.45. So 8.45 with 2 hubs is this whole axle. 8.05 because we deducted 0.41 from it. That means we were 4.27 amps for this hub, but when we added the second hub, if we were to double 4.27, we would be at 8.5, but we were not. Okay, now what we're going to do is we're going to do 3 hubs. 11.8, 11.4 amps is what we come out to be. 11.4 amps with 1, 2, 3 hubs. Now we're going to add the 4th hub. So 14.6 amps. Now what we're going to do is we're going to do 5 hubs. 17.8. So 17.4 amps right there because we deducted 0.4. Now what we're going to do is we're going to do 6 hubs. 20.4. So as you can see, if we did 4.27 times 6, we should have come up with 25.62 amps. But we didn't. We come up with 20.4. So what that shows us is if we mathematically multiply this by our 6, we would have expect 5, almost 6 amps more than we actually received. So we could misdiagnose this thinking that we have hub magnets that are not working because we only received 20 when we were expecting 20.5. And the reason for this being is if we're applying 13.7 to this hub on 14 gauge wire, when we add this guy, we're not getting 14 or 13.7, we're getting 13.5. And then we get over here and we're at 13.2 and so on and so forth. Our voltage is dropping all the way down to maybe 12 all the way over here. So we're getting 12 volts across the board on every one of these magnets by the time it gets there. Even though the source is sending out 13.7, we're not receiving it all the way down through here because you got to remember a lot of these trailers have Scotch locks. They're using screws for ground terminals. Of course, we have the length of the wire and the fact that most of these trailers are built with 14 gauge wire running back there to the brakes. So all of this plays into why we're seeing what we're seeing. So what we've done is we've done our amperage draw in black for lithium, as you guys can see. We're going to retest every bit of this, but we're going to do it on a 12 volt lead acid battery. So here's our lead acid battery that's 12 volts. We're going to verify its resting voltage right now. So our resting voltage on this battery is 12.75 volts. Now, again, when we start adding a load to it, the voltage is going to sag, but I want you guys to see this is a good lead acid battery that's 12 volts. And we're going to see what our amperage draw difference is. Now, the way this is set up, lead acid batteries coming through here, we're going to see amperage here as well as here. I've re-zeroed the meter. Remember, we did verify that our meter and the Tow-Minator were reading correctly a while ago, right on par with one another. So we know that we're not going to get any skewed readings. This go around, we are going to use blue for 12.7 volt lead acid. So on our lead acid test, we're going to be doing it in blue. And we're going to start with 1 hub right here, just like we did with lithium. We're going to do the exact same test. All right. So we flip it on. We are at 3.75 amps. That's for 1 hub. Then we're going to turn on hub 2. We are at 7.30. That is for 2 hubs. We're going to go over here and we're going to do 3 hubs. 10.3 amps. Now let's go with 4 hubs. 13.3, We're going to go with 5 hubs, 15.9. And we're going to go with 6 hubs. We are looking at about 18.3. So this shows us the difference between a lithium holding stable at 13.7 volts as our source versus a lead acid, which is going to sag on voltage. So let's just do some math here. 3.75 times 6. Our expectation would have been 22.5 amps, and we actually ended up with 18.3 if we multiplied this by 6, because again, we have voltage drop across the system, and also our lead acid battery was not maintaining 12.7 volts. It was dropping under load. In fact, we could do a simple test here. We could go back to this guy, the voltmeter, and we'll go to the battery. And what we're going to do is we have all 6 magnets activated. And what we're going to do is we're going to flip this guy on. So you'll notice that now it's resting at 12.64. And we are going to flip the switch on. And our voltage is dropping to about 12.3. So that's showing that when we activate those brakes on a lead acid battery, our voltage is dipping because of the characteristics of a lead acid battery. Now what we're going to do is we're going to switch over to green. I'm going to put in a 6-volt battery just because I know that our systems don't run off 6 volts, but I want to show you guys with the lower voltage we're going to see much different results in our amperage readings. So we have our 6-volt battery hooked up. We're going to do a quick voltage test on this battery to see where it's at with no load. We are at 4.19 volts with it at rest. So 4.19 volts, lead acid, green. So let's do our first test with a single hub. We're going to zero this guy out again. We're going to activate it. We are at 0.13 amps. I think that battery's falling on its face completely under load. So this might be a bad 6-volt battery here, because it appears that when we put a load on it, 4.3 volts, we're going to activate the load, and this battery falls off to 0.13 volts. Turn the load off, and it slowly starts to recover. So this is a bad battery because it will not handle any load at all. So we found another 6-volt lead acid battery. We're going to verify what its resting voltage is. It is resting at 7.05. So we're going to put that right over here. 7.05 volts, and that's lead acid. And we're going to do our amperage draw in green. So we are going to go with 1 hub, so axle 1, and 1 hub turned off. And we're going to check. So our amperage draw there is 2.06. Now what we're going to do is we are going to turn all of axle 1 on. So 2 hubs. Our amperage is 4.03. Now, according to math, if we were 2 amps on hub 1 and we multiply that by 6, we should be at 12 amps when we get over here. Let's see what happens. So what we're going to do is we are going to go 3 hubs, 5.82, and what we're going to do now, flip it on to 4, 7.57, okay, and then 5 hubs is 8.92, okay, and we're going to try 6 hubs, 10.49. So what we were expecting was 12, and we ended up with 10.49. I want you guys to see it doesn't matter if we're using 13.7, 12, 6, doesn't matter. The math works out the same every single time. The only difference is we are using lithium, and we were able to hold a consistent 13.7 out of our source. Our voltage is not sagging like it does on lead acid, so we can see a more consistent flow through there. I hope that this helped give you guys some answers that you may not have had in the past. Let's just see what our amperage draw does over time with the heat of that magnet. So Initial amperage draw is 4.59. So, and we're going to start our timer. 4.59 cold. And we're going to let this thing run for 1 minute. We're already down to 4.2, 3.87. And I'm calling that hot, but it's honestly probably not hot. But as you can see, even over more time, it's still dropping right there. But I want you guys to see that there's no set number as to what those hubs should draw, because it is going to be a variable when they're cold versus when they're heated up versus voltage. There's a lot of things playing into this to give us our amperage draw. Yes, amperage is important to see over here on the Tow-Minator, but you might be stabbing in the dark if you don't realize what could potentially be happening with our amperage draw per wheel along with the voltage drop. Thank you.